Welcome to the second session of the Zeta course. Part 1. The Scientific Method. The scientific method is the best way we have found to understand the world we live in. Science is the practice of the scientific method. Let's look at a simple example of it. Every investigation begins with making observations. How can we explain the observation that a cup of pure water freezes quicker than a cup of salt water? One explanation, or hypothesis, is that the ice fairy makes it happen that way. What's wrong with this explanation? Apart from being implausible, the problem is that this hypothesis cannot be tested. There is no evidence that fairies even exist, let alone why they might behave in this mysterious way. A more plausible hypothesis is that salt water is warmer than the pure water, so it takes longer to freeze. Do you think that salt water is warmer than pure water? We can test this hypothesis by measuring the temperature of the water in each cup before it freezes. The temperatures are always the same, so we can reject this hypothesis because it fails the test. Another hypothesis is that adding salt to water lowers its freezing point, so that it takes longer to freeze. As expected, salt water freezes at a lower temperature. This first test confirms our hypothesis. We can be more confident of our findings if we repeat the experiment a few times. Once our hypothesis is confirmed, we call it a theory. Salt water takes longer to freeze than pure water because salt lowers its freezing point. Our simple theory might develop into a more comprehensive theory that explains a wider range of observations. We can ask more questions such as, does adding more salt lower the freezing point further? After lots of experiments, we would discover Blagden's law. The drop in freezing point is proportional to the concentration of dissolved salt, as shown in this graph. We may need to improve our theory to explain further observations. Frozen salt water doesn't feel as solid as frozen pure water.
We have now waited 24 hours, so let's take a look at our salt water. Okay, so here we have 4. Here is the cup that had water only, and it is solid ice. This next one has 1 teaspoon of salt, and it is pretty solid too, not quite as solid as that one.
Pure water ice crystals form, making the surrounding water saltier. Eventually, this super salty water is surrounded by ice crystals, making a more slushy solid, as shown in this electron microscope image. Only when the temperature is reduced to -21 degrees centigrade does all the pure water freeze, leaving a solid mixture of pure ice crystals and salt crystals. When we are confident about a theory, it's time to share it with the scientific community. Research papers are submitted to scientific journals so that other scientists can check their findings before publication. This is called peer review and ensures that bad science is exposed. Bad science could be the result of poorly conducted research, or bias, or corruption. For example, research funded by the tobacco industry and the oil industry. And then there is sloppy reporting of science, especially if it is sensational. Remember the MMR vaccine scandal, based on the shoddy research of a single GP? Pseudoscience masquerades as science, often for financial gain. For example, food supplements. Astrology. Intelligent design. Alternative medicine. Pseudoscience thrives because of the powerful effect of anecdotal evidence. Evidence collected in a casual or informal manner and relying heavily on personal testimony. For example, in the 1940s, holistic health practitioner Anne Wigmore claimed that the enzymes in chlorophyll in wheatgrass juice heals by detoxifying the body. However, scientists know that eating enzymes and chlorophyll can have no such effect on the body, which is why there are no credible studies in support of her claim. But there is lots of anecdotal evidence. Googling wheatgrass quickly leads to endless compelling personal accounts of healing, like those on the Rotarian forum. People tend not to post negative accounts on these forums, which gives a false impression to their readers. Are these posters lying? No. There are other reasons why people appear to benefit from wheatgrass juice. For example, the placebo effect, or the power of belief that it will work. Other reasons include spontaneous relief, the effect of other medications, change in lifestyle, temporary relief, and so on. Without systematically comparing people who drink wheatgrass juice with similar people who have not, we cannot be sure of its effects. Rather than accepting scientists are currently unable to treat a disease, we desperately hope for some kind of alternative and latch on to any positive message. Apart from the rigour of the scientific method, there's another very good reason to trust in science. It works. Let's have a recap. The scientific method is the best way we have found to understand life, the universe, and everything. Every investigation begins by making observations and carefully collecting evidence. These observations lead us to ask questions and suggest a possible explanation, called a hypothesis. We then need to test the hypothesis in as many ways as possible to see if it explains all of the available evidence. If our hypothesis passes repeated tests, it becomes a tried and tested theory. Our theory may need to be improved to explain new evidence. It may even need to be entirely replaced by a better theory, as we shall see in Part 2. Our findings need to be independently verified by other scientists in order to rule out personal bias, corruption, bad science, and so on. Try the quiz that follows. There are also some issues for discussion.